Juniors, good afternoon. It is Tuesday, March 31st. We're now in our third week of virtual learning. I know for me, I'm starting to feel like I'm getting into a schedule, which has been good. Hopefully you guys are noting, similarities that you're starting to get into a bit of a routine. As I mentioned before, remember your mental health is more important right now than schoolwork. So, you should not be stressing out about school and deadlines and making sure you can meet every Zoom and every expectation of all 8 teachers. Just try your best, get in that routine. Make sure you're getting outside once a day. Make sure you're doing something active once a day, avoiding depression, anxiety, and the things that would be common with this quarantine. So anyways, hope you guys are doing okay. By now you should have turned in your IA to turnitin.com. It is worth somewhere between 0 and 30 marks. I know that's an odd thing to say, but currently the rules are that what we do online is not graded. Those rules could change. If we don't go back to school this year, then that IA will not count. But those rules could change, and then if we do go back to school, I can give you some more feedback, and you could turn those IAs in a second time for a grade. But anyways, I was looking at our schedule. I know I told you we were going to start the populations unit, but I actually think it makes more sense to go right into our real IA since we just finished our practice IA. I think it's fresh in our minds, so we're just going to go ahead and get started on planning and prepping for our real IA. That'll actually take place on Thursday. We're going to have a Zoom meeting at 1:30 p.m. Make sure you bring your IA manual to that meeting. Also make sure you print out the IA proposal document that I'm attaching to this video post. But I would argue Thursday is probably our most important Zoom meeting. I'll post it if you miss the meeting, but if you can, try your best to be there because it's going to really be the kickoff to your real IA, which will be your biggest and most important grade in this class. It'll be a grade for first semester of senior year. It'll also be 25% of your IB diploma. But anyways, we'll get to that on Thursday. What we're doing today is an example secondary data assignment. This is the third type of IA. So obviously the IA we just finished is a hands-on experiment. That's obviously the main type of IA. Another type is a survey. We actually did that back in August, if you remember, when we were asking people in our family and in the community about EVSs, and then we ended up graphing that data. That was like a mini version of a survey IA, but a fairly common one as well, and also fairly easy to do because you can do this from your couch, you can do this just on your computer, is secondary data. So you're doing a study of someone else's work. It's sometimes called a meta-analysis. You're basically looking at other people's data, coming up with something new. So that's what we're going to work on today. And then on Thursday, in live time at 1:30, we will go over the real IA. So go ahead and pause the video right now and make sure that you print out that secondary data assignment. And then once you do that, we can go ahead to the next slide. Okay, so this practice of looking at secondary data, I think it's pretty straightforward to follow through. It's almost like a recipe type lab. Just you can follow this along. You probably don't even need my explanations. You could probably pretty easily follow along and find correlation and causation. We can talk about this later, but correlation just shows that 2 factors appear to do the same thing, whereas correlation is when 2 factors are actually influencing one another. So make sure we know the difference between those. So what you're going to do is go to gapminder.org/data. Once you get to this site, there's hundreds of data sets, and you can just search into their search bar and narrow down into something that's environmental. They have data sets on things like motorcycle accidents, but that probably doesn't apply to us. They also have population data, data on forestation or carbon emissions or rates of cancer, and that stuff obviously does apply to us in ESS. So anyways, find 20 countries or more and find 2 variables that you think might be related to each other. It's important, make sure you read this section right here of the worksheet. It's important that your data variables are standardized, such as percentage or per capita. Like a great example of this would be, let's say you look at total deaths by cancer and you compare the United States to Luxembourg in Europe. Clearly the United States is going to have hundreds of times more deaths by cancer, but that has nothing to do with our rates of smoking or our healthcare system. That's just because the United States is hundreds of times larger than Luxembourg. So you want to make sure that you standardize that, and if you're comparing United States to Luxembourg, you would want to look at how many people die of cancer as a percent, or how many people per capita. Another common value is crude values. Those are values out of 1,000. But anyways, you then find two data points, or two variables, and then you try to make a prediction of how one may influence another. So here's the example I came up with. Make sure you have your independent variable, which is the thing you think will impact the other, and then your dependent variable is what gets impacted because of the independent variable. So anyways, here's my example. Independent variable, average age of marriage. Dependent variable, carbon output from industry and auto. Here's why I think these are related. You can read my prediction. Basically, when women get married at a very young age, they're probably in a poor country, probably an LEDC country, because they have less access to things like education. That's probably going to be a agriculture-based country, so it's probably going to be lower carbon output. A country where women get married older, it's probably a more wealthy MEDC country, more industrialized, so it's probably going to have more carbon output. Now, is this causation? No. It's not that women getting married older literally causes more CO2 to be emitted. It's that women being married older is likely correlated to more CO2. So notice that this might have a correlation, but it probably wouldn't be the best IA topic because we're not looking at clear causation here. But anyways, again, here's where you can pause the video. Search around the Gapminder database, find two variables, make sure you can identify which is the IV, which is the DV, and then discuss a predicted link, including why you think there's a link between these two variables. Okay, once you have your data set, you could do this with hundreds of countries and it would be probably just as easy because it's all going to be cut and pasted into Excel. But as long as you have 20 or more countries, that's fine with me. If you're looking for a randomized correlation, just pick any 20 countries. I do think it's probably better to try to compare two types of countries at once. So you could even like change colors in your scatter plot in Excel and maybe have like 10 to 15 MEDC countries and 10 to 15 LEDC countries, and you can see if your predicted link holds true for both types of countries or maybe just one type. But anyways, I have a screenshot here of what my Excel spreadsheet is going to look like. Column A is the country, column B is my independent variable, column C is my dependent variable. Realize that I standardize these. So average age of marriage is already a standard value, but carbon output per person, I had to make sure that I found the right value because they also had a stat on carbon output in total. That would not be appropriate because that would be skewed by how different our populations are around the world. So once you do this, you're going to make a scatter plot. A scatter plot is the best way, or one of the best ways, to look at correlation and causation. So I have the instructions right here. You go to insert and then chart and then scatter plot. Make sure your IV is the x-axis, your DV is the y-axis. Please note that Excel cannot read anything outside of numbers for column B and C. So like if I had 23.2 years old, that would come up as an error. Excel cannot count that. So make sure you have your units in the axis label, not in the cell itself. And then you guys know how to format charts, by doing halt. So add a header, label the axis, and then you also want to add a correlation coefficient, which is an R-squared value. I have an example here of what your graph should look like. You see my IV, my DV, and then you see I posted my R-squared value. Now, here's where you need to forget what you learned about in physics and in math, because I believe in physics and math, you guys talk about an R-squared value of being like 0.9, 0.95, even 1.0, and looking at these like truly linear relationships. Please realize that in the real world, which is ESS, those perfect 0.9 R values are almost, they almost don't exist. And so if you look at number 2 here, I consider 0.8 of an R-squared value to be really strong, 0.5 or higher to be moderately strong, 0.3 or higher to be weak, and then if it's under 0.2, that's really a non-existent link. So my R-squared value rounds up to 0.5. I would consider that to be a moderate relationship. It's not a straight line, it's not linear, but again, in ESS, it's very rare that you're gonna find two variables that are like an actual linear relationship. But anyways, 0.47 to me shows that there is a clear relationship that when women get married at an older age, they are going to be in a country that is likely to output more carbon. Again, there's going to be outliers. You as the scientist always have, it's your right to remove any outliers. You just need to note that in your graph. There's also another website you can check off for even more accurate results. It's called a Pearson Distribution Index. If you're bored, check it out. We'll get into this more with our real IA, but really what I'm looking for here is that you can create a scatter plot comparing two variables, and you're able to look at correlation and possibly causation. Okay, so once you finish this secondary data assignment, that's it for your classwork today, but just remember your homework, I'll call it, is to print out the IA proposal so we can look at that on Thursday during our Zoom meeting. Also, make sure that you bring your IA manual to the Zoom meeting. We're going to be focused on pages 5 through 7, so it's not a bad idea to read page 5 through 7 ahead of time, especially if you want to bring questions. But again, that's it for today. As I mentioned, Thursday's meeting is fairly important because we're going to get into our real IA, which is exciting. Hopefully some of you guys can look forward to. That's it for Tuesday the 31st, and I will see you guys Thursday at 1:30. Okay, see you then. Be safe. Bye. This is a preview of our meeting on Thursday. Feel free to look through this. Make sure you have brought the documents, and I'll see you guys at 1:30.